Okay, this is 2010 number 6, and this is a non-calculator question. It says, and this is, by the way, a very popular question that they like to put on the AP exam. It says, solutions to the differential equation dy dx equals xy cubed also satisfy d squared y dx squared equals this function. So essentially, this is the first derivative equaling this, and this is the second derivative equaling this function. It says, let y equal f of x be a particular solution to the differential equation dy dx equals xy cubed with f of 1 equals 2. Now, we have not actually learned how to solve differential equations when we have two different variables on one side. You guys have learned how to do it when there's just x's and you just multiply the dx over and take the integral of both sides and plug in the initial condition. But we haven't done it when there's more than one variable on both sides. And so we're going to not be able to answer part C to this problem. So just keep that in mind already, is that part C is off limits until we actually learn how to do that, which is the most heavily weighted part of this problem. So we're only going to get to the first two. But you should be able to do the first two without having to do part C. And again, I like doing that because even though you're not able to do part C right now, I want you guys to realize that when the AP test comes closer, that if you're actually taking the test and you're in the middle of it and you don't remember how to do part C, you can still earn the points from the other ones, and you already have the knowledge to be able to do so. So I want to help you guys through that. So this is just a particular solution. It just means that we can take the integral of this to actually find out what the original function is. And it gives us this initial condition f of 1 equals 2. So part A, write an equation of the line tangent to the graph of y equals f of x at x equals 1. Now, I hope that sounds very familiar because that's right off of your SIG test. I believe it was SIG test number 14, tangent lines. And so this literally tells you to do, honestly, part A and B is exactly like your SIG test. So hopefully it looks very familiar from what we were doing there. So in order to write a tangent line equation, we need two things. We need a point, which, good news, we already have one. They gave us this initial condition. And we also need a slope. And remember that the derivative, dy dx, can help us find the slope. So essentially, I need to know what the slope is at this point, 1, 2. So if I plug in 1 for x and 2 for y, I should be able to figure out what the slope of this line is. And then I can plug it into point slope form. So coming over here to my work. And again, here's the topics. Notice that I crossed out the one for part C because we don't know how to do that one yet. But for part A, notice that I have, there we go. I have point slope form. I know that my point is 1, 2, and my slope, again, if I plug it into the first derivative, 1 and then 2 cubed would be 8. So my slope is 8. So if you plug that into point slope form, you get y minus 2 equals 8 times x minus 1. So super easy, super basic. That's going back to like algebra 1 business. The only thing you have to understand about that is that dy dx represents the derivative. So notice that you get 2 points for that. All right, you get 1 point for getting the slope correct, which is 8, and you get 1 point for actually getting the equation of the line. Now remember, you don't actually have to put this into slope-intercept form. You can leave it in point slope form. They move the 2 over to this side. They obviously feel more comfortable with that, just isolating y. You should get the points though if you didn't move it over to the other side, like I did not write it in mine previously. So that's part A. Part B says use the tangent line equation from part A to approximate f of 1.1. Now again, every time you see this word approximate, please do not go through and actually find the integral. Now, good thing now is that you don't actually know how to yet, so that's good. A lot of you guys, though, get tempted to do that. You actually get tempted to find the integral and actually plug in 1.1. But they do not want that. They want an approximation of 1.1. So it says use the tangent line that we just found to approximate f of 1.1. So I literally want to plug in 1.1 here to x. So let's do that. So when I plug in 1.1 right here, I get 1.1 minus 1, that's 0.1, and then multiply that times 8, that's 0.8, and then add 2, so it's 2.8. The next part of that same question says, given that f of x is greater than 0, I think that's a typo. I think it's supposed to be f double prime of x, so I'll let you check that later, but I'm almost positive that's supposed to be f double prime of x, and we'll see why in just a minute. So given that it's greater than 0 for 1 to 1.1, it says, is the approximation for f of 1.1 greater than or less than f of 1.1? And explain your reasoning. Now, I wanted to verify that they actually did mean f double prime of x here. So I actually plugged in this point 1, 2 into the second derivative to figure out if it was positive or negative. So I plugged 1, 2 in here, and I got, when I plugged in 1, 2, I got 104, which is positive. So remember that positive second derivative indicates that the graph is concave up at that point. So I drew a little concave up graph right here. And then I drew a tangent line. So we'll pretend that's the tangent line at 1. And so you'll notice that at 1.1, the tangent line is underneath the curve. So because it's underneath the curve, it's an under approximation. So to answer their question and to offer justification, I said because the second derivative is positive, then the tangent line lies underneath the curve and is an under approximation, which means our approximation is less than f of 1.1, the actual value. And again, just to show you guys the two exaggerations, here's our approximation, and here's the actual value of f of 1.1. And notice that the purple dot is below the red dot because, again, it's concave up, so it's an under approximation. Alright, so from there, let's see how many points that was worth. That was also worth 2 points. So you get 1 point for getting the approximation of 2.8 and 1 point for your conclusion. So again, look that they said that because f of x is positive, then that implies the second derivative is positive as well, but I think that should be double prime. So it says, therefore, on the interval, the line tangent to the graph of f lies below the curve, like we just drew, and the approximation 2.8 is less than f of 1.1, like we just said. And again, we don't know how to do part C yet, so we're not even going to look at part C, but notice that you could have gotten 4 points just by doing that, and that was straight off of your SIG test. So you guys should be plenty comfortable with that.